Okay, hi again, everyone. I think the journey has, in fact, taken a good progress going all the way from speaking about the 6G ambitious sort of platforms and landscapes and communication and computation and networking and their intersection and their union. I think at this stage we are heading towards, in a way, just capturing the main conclusions and to try to see whether the audience would have any questions. Okay, so of course, so far in the talk or in today's tutorial, we've come across that 6G research initiatives, both in industry and in academia. We touch upon some of those big goals, where multi-tier computing and going all the way from that traditional radio access network towards the provisioned CRANs and towards the over-provisioned, in a way, multi-CRAN and hybrid cloud mobile edge computing system, the coexisting of all of which eventually is bound to bring or to realize the most important metrics of 6G and beyond. All right, so this was a basic motivation we started aspiring for. We need, of course, we have to have an optimized or quasi-optimized performance based on what particular numerical aspects or challenges we've got. Of course, one of the goals eventually is to get into some of those reduced latency, optimized performance, enhanced efficiency, energy efficiency, or enhanced data rate metric, or maybe fairness as well for some of those schemes of connecting and over connecting devices and users. Okay, what we spoke about today in particular is bound to in a way create these sort of whereabouts of multi-tier computings where where we can benefit from some of those what we call the graceful failure, and also having some of those opportunistic connectivity between the private and public cloud, between the mobile edge users, the XR devices, the end devices, the UAVs, the mobile edge computers, and so on and so forth. So I think we've highlighted all of those, and in today's talk we spoke about, of course, the traditional or maybe the cloud radio access networks, centralized processors, computation and communication prospects. We spoke about the challenges and why do we need eventually to go into much more sort of sophisticated schemes. Of course, CRAN provides excellent platform for virtualized and flexible networks for efficient radio resource allocation, but they've still got some issues in terms of latency, in terms of their capability to truly and practically implement some of those complex algorithms. That's why we moved on towards multiple cloud run. In multiple cloud run, now we are trying to distribute the computation and the communication, to distribute the intelligence across the network, and eventually try to exchange some particular reasonable amount of information between the different clouds to achieve some important metric from a communication and computation perspective. Of course, here the multi-cloud RAN would provide a flexible network, would still benefit from the advantage of CRAN, but at the same time, it provides a more practical and more vastly spread type of coverage and connectivity across systems. It takes into consideration several things that are practical, but at the same time, we need to look into situation where we may not have truly available clouds at the edges, and that's why we looked into into mobile edge computers, which coexist with the important features of cloud, and that's why we look into the highly flexible architecture of multi-tier computing systems. We look into the rate splitting aspect into hybrid cloud and mobile edge computer. We looked also at another problem where we had extended reality system, and we are also trying to see the combined or amalgamated benefit of both cooperative NOMA from a multiple access scheme and multi-tier computing from an actual computer and from actual computing and communication capabilities. So we discussed this importance, especially from the angle of no single point of failure, from the flexible access perspective. We discussed from a rate splitting perspective, we spoke about robustness to interference and the capability to do um, rate splitting at the transmitter and common message decoding at the receiver side. But we also looked into the resilience of blockages in extended reality type of systems, in XR systems, by enabling the cooperative NOMA, cooperative non-orthogonal multiple access advantages. When we spoke about also the online type of solution, we came across the AI-based joint communication and computation. We describe how eventually we can look into some of those joint uncertainty in communication in the channel as well as in the resources. We actually devised some practical useful algorithm from that particular perspective based on some artificial intelligence based technique, especially by building a network or a neural network based on the concept of joint uncertainty and joint uncertainty of in communication and computation and injection perspective. By injecting the proper uncertainty, one can actually do very well, and that was one of the important aspects we highlighted. We highlighted how we can provide a robust service in terms of uncertain channels and computation, and of course. One of the main messages in this particular tutorial is that multi-tier computing is in fact extremely promising, not just for numerical sort of algorithmic implementation, but also for enhancing the 6G systems, 6G network, by bringing up the advantages and bringing together the benefits of communication and computation by actually checking how things could be done both at the core and at the edge. How do they work together for bringing up the enhanced network resilience? How can they improve the energy efficiency, which is a very important metric from a sustainability perspective? How can they improve the throughput, which should always be the mother of all measures in communication from a rate achievable rate perspective, from a Shannon achievable rate perspective. We spoke about how we can get the interference mitigation, how we can achieve high interference mitigation capabilities in rate splitting and common message decoding perspective, in extended reality and cooperative NOMA perspective, also by accounting for both the delay and the computational constraints. So this is it about the tutorial. We hope that you all have enjoyed it. We also thank the audience about their interest. We hope this tutorial in a way has put several topics in an organized fashion together. Of course, if you have any questions, we'll be happy to answer those questions. These are mine and my colleagues' email contacts. Please feel free to contact us in an offline fashion. We'll be very happy to connect with you. The papers are all also, in a way, most of the papers related to the tutorial were inside the slides, so we'll be happy to connect in an offline fashion, or just ask your, or just answer your question now online as well. Thank you very much, and we'll be happy to take any questions now.